Hi all, welcome back to the third session of this week. In this week, we were discussing about the containerization, Docker containers, Docker file. There are a lot of things that we already discussed. We know that Docker and containerization is one of the latest kind of deployment strategy that we are adopting in the world of IT. So when it comes to deployment of an application or a group of applications, we just go through the historical era where how it was in the previous when the deployment and all these technologies coming to be, and then we just go through those timeline, like from the traditional deployment era to the virtualization and to the containerization. So today we'll be mainly discussing or mainly focusing on Kubernetes. So we just had an introduction of Kubernetes in the last session. So there we have a discussion about what or how that is happening. So it's similar to that containerization, but it is kind of an orchestration tool that we will be using to manage the newly created or the created containers. Right? So we'll be mainly creating containers with the help of Docker. So we will define some Docker files and we'll create some containers with the help of those Docker files. Yeah, and we know that we need to build those Docker file first. So we will get a Docker image. From there, we need to run that image. So as an outcome, we will get a container. So we'll be exploring more into Kubernetes, so-called K8s. That's how we can call that as easily. So it's Kubernetes actually, K8s. Okay. So without any further delay and all, yeah, I will be starting. So do you know what is Kubernetes? We had a session last, no?
Yes, sir. I mean, it's the advanced level of Docker. I mean, Docker is limited for some sort of things, and Kubernetes is beyond the Docker. I mean, where the Docker stops its working limit, then the Kubernetes thing starts. It has more varieties in containers and all. So it's actually more advanced in Docker.
Yeah, it's to an extent, yeah, your concept is clear, and it's correct also, always. And yeah, more than that perspective, it is like if we have an enormous amount of simple containers also. Let's say I give an example, no, 1,000 containers or something. So it's pretty much difficult to handle all those things. So for that, actually, we use this kind of orchestration tools. So Kubernetes is one of the orchestration tool that we will be using to manage the containers that we will have, which is created as part of any Docker files or something. Or maybe we'll be creating containers with the help of YAML files as well. So basically managing containers for deploying, scaling, that kind of things can be taken care with the help of Kubernetes. So that's how it is actually. So good, at least you have an idea on what is Kubernetes. That's great. So we'll be discussing that topic today. So let us consider if if someone asks what is Kubernetes, right? So it is something like a platform, right? It's a platform itself that mainly manages what containerized based application, or we can call it as containers mainly, because what we are doing in containers, definitely we are deploying some applications, no? So we can call it as that manages some containerized based application. And not only the container based application, it will be managing the associated networking and the storage and all. Okay, so KTS will be managing what? Containerized,
Containers.
yeah, based container based application. These applications, as well as its related network components or networking part, plus its storage components. Okay, so it's actually it is rapidly evolving, which means the updates are pretty much fast. Okay. So this is the basic concept that we need to understand. And the main part in the sense, Kubernetes mainly focuses on this area, means, or we can call it as, this is an application, right? Maybe we can call it as an application because the container, the applications and the network and the storage, we will call it as application. Okay. So Kubernetes will mainly focus on this workloads, which means the application workload. Okay. That is not much concerned about the infrastructure components or whatever. Okay. So the main focus is on what? Focuses on application workloads. Okay. So you just need to understand Kubernetes. KTS is something like, it's basically a managing containerized based applications and its networks and the storage, and mainly focuses on the application workloads as well. So it is not bothered much about the infrastructure components it's have. And there is, it's a declarative approach to deployments, in the sense like you will be having, we can handle that in different ways. So either we can run, like we can build and run now those kind of applications. So mainly some microservices architecture that we have discussed now. So that kind of applications we can easily manage with the help of Kubernetes. So mainly to orchestrate and manage that. Yeah, the term you just need to keep in mind is availability. Okay. So we are bringing this to increase the availability of the application. So as I said, no, like whether we will be approaching microservice architecture or something. Yeah, basically we'll be building and running those like services, microservices based application with the help of Kubernetes. So we can easily orchestrate that action. So it will mainly support both in the sense, both there are two kind of applications. Okay, stateful, stateless, and stateful. Do you know what is stateless and stateful?
No, sir.
Yeah, it is.
Never heard about it.
Yeah, okay. Yeah, this is a term. Whether it will be, I'll explain you in an easy manner. So you can say that stateless is something like it will not have any database. Okay, no DB. DB means there is no database. Okay, only web layer or something will be there, like only HTML core or something will be there. There will be no databases aligned or associated with that. We can easily explain like that. So when it comes to stateful, it will have some databases or some storages, we can say. Okay. So stateless is something like it will not have any storage kind of thing, but in stateful, there will be some storage mechanism or something. Okay. Yeah, there will be some applications, some applications which will not have any database or storage or kind of thing. Then it comes under stateless. When it comes to stateful, yeah, there will be some storage or something associated with that application. Okay, got it?
Yes, sir, got it.
Yeah. And the advantages of Kubernetes is one more thing, like if we have, as we know, it's an open platform. Do you know who developed Kubernetes?
No, sir, not really.
Okay.
But I mean, it's a Microsoft platform, right? Or it's a third party.
It's developed by Google.
Okay.
Okay, and now it is managed by the CNCF, Cloud Native Computing Foundation, actually. Okay. It is now handling by CNCF, but it's developed by Google.
Okay.
So most of all think that it is developed by Microsoft or something, but it is not like that. It is developed by Google, and currently it is managed by CNCF. You can go and search for CNCF, so you will get more idea.
So it's a third party then.
Yeah, it's a foundation, so that they do have some communities and all of that.
Docker itself is a third party, or?
Sorry?
I mean, what about Docker? Docker, I mean, it's a third party. I mean, is it the same as Kubernetes, like a third party?
No. This Docker is, yeah, something similar to that, but it is like Docker is developed by, what we can say, Docker itself. We can say that, yeah, because Docker is a separate company as well. Yeah, there are different there are different runtimes for containers. There are Containerd. Okay. Containerd is one of the runtime. Basically, it is for like running the containers. Now, setting up the environments to run some containers. No, so
yeah,
either it is Docker engine or Containerd, like it will helps to run this containers. So actually now in the latest version, Kubernetes and all is mainly AKS is using container. It is like a runtime software. Okay.
Okay.
Okay. If you heard about Containerd, just understand it was a runtime software. Okay.
Runtime software. Okay.
Yeah. And so I said no, like we can use the CI/CD and all, means continuous integration and continuous development. We will come to this later, but not now. So we can rely on CI/CD, whatever we are using, or if some company is using some CI/CD pipelines and all, yeah, definitely they can be a part, like they can do that, and they can integrate Kubernetes with that CI/CDs, and they can schedule and deploy their releases as well. So it's like that, and yeah, Kubernetes, it's a big concept, which means it's a little bit confusing. So that's why I'm taking one by one. And today also, like we will be covering the most of the concepts also. So you can just go through the last video that's last session. No, you can go through the recording. Also, you can go through the today's recording as well. And then, yeah, next day, tomorrow, we can have some labs on it. So make sure you are watching these 2 videos prior to the lab. Okay.
Okay, sir.
That's that much important actually it was. That's why even if it is like you are not able to do the entire lab, but you have to make sure that the concept is pretty clear to you. Okay. So that's what I need in this week, because that's pretty much important.
Okay, sir. We'll definitely go through the
Yeah,
previous session and this
yeah,
session.
highly appreciated that. So yeah, when it comes to AKS, actually AKS is something like a managed Kubernetes. Okay, managed KHS. So if it is managed KHS, then there should be something else also. Yeah, we have something else called self-hosted KHS. Okay. So there are mainly 2 kinds of Kubernetes. One is managed and another is self-hosted. Okay, I'll come to this. Okay. So yeah, these are the main concepts that we have. So yeah, just wanted to give you an introduction on what is Kubernetes and how these are working, like how much it is focusing on what we have some, like what kind of workloads it will deal and all. Okay, and what kind of Kubernetes it will have. So AKS comes under managed Kubernetes. Okay. So as I said, no, there will be like one will be supporting and managed Kubernetes, but self-hosted will be like we need to take care of all of these things. So let it be here for now. Let me. So I'm explaining, like I'll be starting the architecture of the Kubernetes. So when you are good confused, let me know so that I can help you out. Okay.
Okay, sir.
So basically, yeah, I'll be starting from the smallest unit. Okay. So let us consider, okay, I have C1, which is container, one container. Okay. There is another container for me, C2. Okay. Which is resides in a virtual machine. Okay. Similarly, I have another VM in place where I have another 3 containers. Okay. So these are virtual machines basically. Okay, we can call it as VM1 and VM2. So we have containers C1, C2, C3, C4, C5, all are containers. And
Okay.
there is one grouping. Okay, grouping of these containers. Okay, I can call it here, it will be like this. Okay, these containers are grouped like this. Let it be like that. Okay. So, and I have one. I have one component here. Okay, which will work, which will always monitor this segregation. Okay. I will call this thing as a pod. Okay. So these are pods. Okay. And I have one component which is always like it acts like an agent, and what it is doing is it will be work as an agent. Okay. And it will be mainly orchestrating the request from that they are getting from the outside. Okay. So like if they have something like it acts like, definitely it acts as an agent, so it can like coordinate or orchestrate the request that this component is getting. Okay, this agent is getting from outside. So that is called kubelet. Okay, kubelet is nothing but it's an agent. Okay, so that will process the orchestration or the orchestrations or the request and all that is getting to this like VM. Okay, so if something is coming to VM1, then it this agent kubelet agent will be handling that kind of what request. Okay, whether it is regarding something regarding maintaining this container or managing the container, like that, all those kind of activities will be taken care of this kubelet. Okay, whatever we have here, same way we have here now. Okay. Okay, so definitely I will have this kubelet here also. Okay, it will be doing it. This agent will be continuously monitoring and it will orchestrate the request that it is getting from outside. Okay.
So does it mean like if we want to reach to the containers, so does it, I mean, does it mean that we have to go through the kubelet?
No, it is not like that. Yeah, I'll come to that. So this kubelet is an agent that will orchestrate all those requests that is getting from outside, which means whether we need to create, like we have a vacant container, which means we don't, is there any container available that we can deploy an application, or any container which is having some issues like it is not started or failing, or maybe some health issues or something like that. Okay, so this agent will be mainly focused on that. Okay, and even in case of scheduling, means if we need to have a new container or in that kind of things, actually Kubernetes is doing that. So some kind of administration, we can call it as like that,
Okay.
like monitoring and managing and kind of things. Okay.
Okay. Okay.
And I do have another thing called kube proxy. Okay. Similarly, here also I have that. Okay. Proxy. What proxy is doing is mainly it is managing the networking. Okay. Networking or the traffic, like managing IP addressing and all. Okay. So if someone need to access this containers and all, then that will be handled by what? This queue proxy. Okay, so it will be mainly handling networking.
The accessing part.
Yeah, the accessing part, the networking, the routing.
External part, yeah.
Yeah, like the virtual networking part of each node will be, each VM will be taken care by this queue proxy. Okay, so if someone need to access C1 or C2 or this port, then what? That can be controlled by this queue proxy. So all those contain what virtual networking for network traffic and all those kinds of things. Also, the managing IP addresses, all those things will be taken care by queue proxy. Okay. Is that fine?
Yeah, yes, sir. Got it.
Okay. And yes, we have container runtime. Okay. Which means I told you, one software that help us to run containers.
Yeah.
Yeah. So it will always, this will be helping what containers to run. So either Docker or I told you, container D or something. It will be there. So similarly, I'll make it as container runtime. Okay. Or container runtime interface. I am called like that. And it is also here. Okay. So container runtime is mainly what it allows that containerized applications to run and interact with other resources. Okay, so it is like it is providing a platform to run, to interact, and all. Okay, so collectively, yeah, we have containers. So we will group it as pod. So here we have one pod, but here we have how many pods? Two pods, right? So, and we have kubelet, kubeproxy, container runtime. Okay, actually everything is under what? VM now. So actually this VM is called a node. Okay, so we can call this as nodes. Okay, basically it's a VM, but we will call it as nodes. Okay. So what is nodes actually? What should be nodes? Because our containers are residing inside these nodes, no? So nodes are something like to run our applications or services and all that will be deployed or that will be running in a node. Okay, so each cluster will have at least one node. Okay, here we have two, no? So at least one node we have. So node is similar to what? Virtual machine, lightweight virtual machine we can call, or a virtual machine we can call it. Okay, so did you get the node concept?
So you mean like node and virtual machines, like both the same?
Yeah, see, like it is a virtual machine, but we will in Kubernetes we will call as node. That's it.
Oh, okay. Same thing but different name.
Yeah, different name. Yeah.
Okay.
You can understand. You can take it as a VM, but we will code as a node because like we will have multiple nodes in the sometimes. Anyway, we must have one node in AKS. Okay. At least one node must be there. So, which means at least one VM will be there. That's it. Okay.
Okay.
And sounds good, no?
Yeah, is it correct? I mean, nodes and virtual machine, like both
Yes,
the
yes,
same
yes.
thing, but in Kubernetes we call it as nodes, and in
Yes, yes.
general we call it virtual machine.
Correct. Exactly. I'm mentioning it. Okay. And we can call this as worker or node plane. Okay. We can call it as worker plane or node planes, like that. Okay. We'll call it like that actually. So this is the worker part, which means our applications are deployed over here. So we'll be using Kubernetes for like managing that kind of what the scheduling,
Containers.
or we need to know whether we have something available there, like that. All those stuff we will be taking from here. Proxy we will be using in terms of networking and all. Someone who needs to access this, then according to this rules and all that we have in proxy, they will be accessing that ports and all. And container runtime, it will be providing that environment that it allows to run and interact with the services, so the resources. So collectively, we will call it as a worker plane or node plane, or we can say it like that. Okay, which means our main application content is deployed in worker. Okay, or we can call it just nodes also.
Same sounds like a subnet.
We can call it as a subnet, but it is like, rather than that, this will be on this is where our application workloads run. Okay, so we can call it as what is, even if it is a single, like these are different VMs, we can call it as this is a server which is handling 2 VMs, like that we can consider. Okay.
Okay.
And now I'm taking this much time because I need to make sure that you are understanding it in the right manner. That's why. Okay. And now I have something else for you. Okay. And yeah, I'll introduce something more. Okay, so this is basically worker node. Okay, and I have another part also. So I have API server. Okay, I have API server means this API server will be in touch with Like, yeah, I'll tell you. So API server will be mainly used to access, like Kubernetes will be having some kind of what networking rules and all, right, to access that containers. API server will help us to connect to this because it will give us an API so that we can connect to this API. Okay. So if someone is connecting from his laptop,
is it like a Bastion?
We can, yeah, for example, if we are taking an SSH or something, no, like that, this API server we can use to connect. Okay, yeah, something like Bastion or something that we can mention, but it is like actually we there is one command kubectl. Okay, kubectl is a command that we will mainly using to interact with this ports. So this API server will be the point of contact. So if someone who needs to connect to this port, he needs to connect to API server. Okay. Do you get this?
Yeah, yes, got.
Okay, I'll come to that so that you will get an idea. So it is like the duty of the IPS server is to expose the like interaction between expose the interaction with the containers with the help of some tools or something. Okay, kubectl is one of the command that we will be using, the tool that we will be using to interact with the Kubernetes clusters, means Kubernetes containers, ports, and all. Okay.
Okay, so kubectl is a command, and API server is the way to connect to
our nodes and our containers, our ports, and all. Yeah.
Okay.
And there is one more thing. We have etcd. Okay, etcd, actually etcd is a, do you know this this kind of symbol? Normally this type of symbol is used for databases. Okay.
Yeah, I've seen this before.
Yeah, etcd. Okay, etcd is something, yeah, definitely it's something like a key value store database. Okay, mainly it is used to maintain the state of the cluster, which means if this is having some configurations and all, it will be stored over here. Okay, so that the details of that cluster and all things will be stored over here.
Okay. You mean the code? The code will be stored over there?
Not code. Yeah. How many like how many this thing? What are the configurations of the ports? Like what are the SKUs? How much capacities have? How many numbers it have? How many nodes we have? And what are the configurations? A lot of things there. You know, like we have some these things, networking rules inside. Also, we have which kind of container runtime we are using, and there are a lot of things we need to store somewhere now, because otherwise, like we need to, like where we can refer it. So we need to save it in some databases. That's why it is really that we are using. It's a key value pair database actually. Storage. Got it?
Okay, sir. Yes, I got it.
Yeah. So if if I need to get to the etcd, like need to collect the configurations, mainly here the configuration will be saved. No, so if I need to get some configurations of this cluster, then I need to go to API server and then I need to go to etcd. Like, so from this API server I will get the details because etcd is in connection with API server. Okay, and there are two more things. One is scheduler. Okay. So with the help of scheduler, actually API server will be, I'll come to that. I'll say scheduler, and we have another component called control manager. Okay. So these are talking to each other. And we have this node now. This node will be in connection with the scheduler. Okay. And this kubelet is also in connection with this scheduler. So what happens is, what is control manager or the scheduler will do? Like if you are creating or scaling some applications, this scheduler determines which nodes, okay, which nodes can run that workload. So it will be checking with the kubelet, okay, do you have any containers or ports available or the nodes available? Okay, here let's say these two are like completely filled, means already deployed. Okay, we have this node. Okay, then C4 is vacant. Okay, then that kind of things will be taken care by scheduler. So what happens? This kubelets know, right? How many containers or how many ports it will have, how many are already deployed, how many are vacant and all, right? So this scheduler will communicate with this kubelet part, okay, of every node. Do you get that?
So basically, the kubelet is sending the information about the availability and all to the scheduler, right?
Definitely, exactly.
Okay.
So the scheduler will, accordingly, the scheduler will decide, okay, where I need to deploy the new application, which node I need to select, or which container I need to choose. Like that, it will be like this will get the data from kubelet because it already have that data now.
Yeah.
Because that is administrative component, that agent that we have in every node. So if it is not possible in this node, then it will go to this node. That's it. But for every node, we have this kind of setup now. There may be different number of ports and all, but we have these kind of like components.
Okay.
And
but sir, let's say if the C1 and C2, I mean both the containers are full already, so in that scenario, like what exactly would the kubelet will do?
yeah,
because
like
we don't have any more containers.
yeah, for example, this is node 1. Let us say this is node 1 and this is node 2. Okay, for example. So here if we say both are already filled, the scheduler is already connected with the node 2's kubelet as well. It is not only connecting with the node 1, it is connecting to every kubelet that is residing inside every node. If they have like 100 nodes, for example, to every kubelet, 100 kubelets, the schedulers are connected. To get that idea.
Okay.
So let's say here everything is filled and we see that C5 is not filled, then it will identify scheduler like kubelet. No, this is vacant. So this kubelet will tell to scheduler that, okay, I have C5 as vacant, you can deploy it over here. Then scheduler will schedule that deployment.
Okay, okay.
Correct.
But in this case, like, do we have to pay them, or I mean, it will be automatically paid?
Yeah, I'll come to that. I'll come to that. Okay. Currently, I'm just describing the duties and the description, or I can say what are the duties of the components.
Okay.
Okay. And
Okay.
and it's good to go now.
Yeah.
Okay.
Yes, sir.
Okay, fine. And this control manager, actually, this control manager is like it is controlling mainly, like it will oversee all the small. There are a lot of simple, like small containers inside that. So it will be mainly oversees that containers, which will like that controllers will be performing some actions like yeah, how many copies you need, or there will be different operations, no, with this nodes. In this node, there will be a lot of operations happen in terms of like scaling, or maybe like creating copies, like that, no. So there will be different small containers. So that containers will be overseeing with the help of this control manager. Okay, that's the duty of that control manager.
Okay. I mean, sir, copies about what? Copies about the application or the data?
Yeah, like there will be copies means, for example, here I have one port now. So maybe in my deployment, like my YAML file, I just mentioned, okay, I need replica of this port, 2 replicas. Replicas means exact the copy of this port. I'm saying like that. So I'll be having an exact copy of this port inside this node. Got it? So it is to increase the availability of the application. Even if this port down, the other port will be there, like that.
Okay.
Okay, there are different controllers like node controller. Node controller is something like it is like noticing whether that like the node is going down or not. Like it is that VM is going up down due to some issues or something. So one node controller is there, which is responsible for noticing and responding when a node is going down. Okay, like that, there is another controller called job controller, which is already always batches for the jobs, and it will create, like it will like control the creation of the pods if needed. Okay, and there are different kind of controllers like that. So the main idea is like it is controlling the processes actually. It will reduce the complexity of that. So mainly you can mention control manager controls the nodes and ports and all inside the worker nodes. That you can call it like that. Okay.
Okay, sir. Yes, sir. Okay.
And yeah. So this is the control plane. Okay. This is the worker plane now. This is the control plane. So there are a lot of like complex actions and all comes inside control plane. And what happens is Okay. This control plane will be managed by Azure.
Okay.
So in AKS, we only need to manage what these nodes or worker plane and only the nodes that we have. Everything like the scheduling or the all this connecting part and everything will be taken care of what Azure. So they will, once we created an AKS cluster, so actually like these both these components, no, this will be comes together and we will call as cluster. Okay, KHS cluster, which means Kubernetes cluster.
Okay.
Okay, so these kind of activities, whether storing the configurations or controlling the activities that is having, or maybe checking or like scheduling the ports and or maybe like arranging the API server, everything will be handled by Azure. We don't need to think about it. Okay. And here you need to understand one more thing. API server is the one component that will be connecting to all other components that is we have in control plane. Okay. So this part will be taken care by Azure. So we don't need to think about it. We don't need to care about it. So whenever we are creating a Kubernetes cluster, this will be automatically created by Azure and managed by Azure. We don't need to think about it.
Okay.
Okay. So we will get a API of this. So we can use that API to connect to that cluster. So we'll be able to establish the connection.
Okay.
Okay. And from there we can easily connect to this VMs, means so-called nodes. And we only need to concentrate on where the deployment of the application. So whether we need to deploy the application in 2 containers or 2 ports or something, that we can decide.
Okay.
Okay.
And also, sir, together both, I mean, the managed by Azure thing and the work nodes thing together, both would call as the normal Kubernetes, right?
Yeah, together that will call as a normal Kubernetes. So
Okay.
if it is
Which will be so
like,
tricky.
yeah, that's why that's the difference. That's the difference means when it's managed by Azure or it may be for AWS, they have something, no? For GCP also there are something. So if it is managed by Azure or AWS or GCP or any other cloud provider or something, then that will be called as, I told you, there are 2 kind of,
Yeah.
that is called
One
managed.
is the AKS. Yeah.
Managed Kubernetes. Okay. So for
Yes,
Azure it is AKS. For
okay.
AWS it is EKS, and GCP it is GKE.
Okay.
Azure Kubernetes Service, Elastic Kubernetes Service, Google Kubernetes Engine. And
Okay.
if it is not managed by any of these cloud provider, or we need to manage control plane and worker plane. Okay. Let's say, let's consider if we need to manage control plane as well as the worker plane, then we need to go with self-hosted KS.
Self-hosted Kubernetes. Okay.
Yes. So the main difference is in managed Kubernetes, the control plane will be take care of the provider. In self-hosted Kubernetes, we need to manage control plane and the worker.
Yeah. But so far, we got like 3 major platforms like Azure, AWS, and GCP, and all of them are managing the control panel. So we don't need to. I mean, as of now, we don't need to think of that.
Yeah. Since it is a managed Kubernetes cluster, we don't need to worry about it. They will be managing that.
Yes.
Okay. So if it is by the Azure or AWS or GCP or some other cloud provider that is providing managed Kubernetes, then we don't need to care about that control plane plan. Only we need to think about the this worker area.
Worker nodes. Yeah.
Okay. Now I'll give you something that is interesting. I'll give you some nature diagrams too, because this is not when I'm drawing it will be little bit ugly. But I can't directly introduce this entire part to you directly. That's why I just see this is how this is an Azure managed, this is customer managed. So I said, no,
Okay.
we have API server, HCD, control manager, scheduler. We have different nodes, kubelet, kubeflow, container runtime. This is what is that container, that pod and all comes here.
Okay.
So that's why I bring it after. Otherwise, like it will be a little bit confusing.
Yeah, it's tricky, sir, and I mean it's difficult to understand. Whereas, like, I mean, the diagram which you have just drawn is quite simple comparatively to this.
Yeah, that's why I put like that. But in yeah, even if it is you search on YouTube or something, no, most of them may be starting from the like entire infrastructure. So it will be. I feel like it is very difficult to look into a big picture and lot of components and identify what is what and all. Rather than
Yeah.
it will be better to understand like from a single component. So we can easily connect to that.
Yeah.
I hope it helps you.
Yes, sir. Definitely, it's helping me. But sir, also, what exactly does the CRI is doing there?
Yes, here's container runtime, which means it is a
Yeah,
software
it's
that we
running.
need to
Oh,
be in present to run that container and all. If it is not there,
okay.
it will we can't run the containers.
Okay.
Simply like for example, we install a Docker now inside that VM.
Yeah. Yes.
Without the Docker, we can't create a Docker file now. Like
Okay.
we
So it's
can
a
create a
separate
Docker
software.
file, but we can't build that because there is no platform that supports that file. Correct.
So it means, I mean, in this Kubernetes, like CRI, is it a separate software which only I mean, which only like runs the entire thing,
It
runs the
is like a
containers?
service. It is like a service actually. So when
Okay.
we use a certain commands or something that service that can be that we can use.
Okay.
So this service is provided by Azure or AWS or something like that. And if we need to think about self-hosted one, then we can configure it in like let's say we can take one VM as control plane and one another VM as a node. Let's say an example of that. If we are thinking about a self-hosted and see here it's an Azure Virtual Machines of Kubernetes. This is the main description of what we have. So kubeproxy, I told you know, it is related to that network part, so it will mention who can access and all. So and kubelet will be in connection with yeah, this is it.
Okay.
Is that fine?
Yeah. Yes, sir. Okay.
Okay. And yeah, when it comes to the size and all, like the memory, CPU and all, like whether we need to go with the SSD or HDD and all, like it is like it is completely dependent upon the Azure VM size itself. Okay. We don't need to
Okay.
think about that. So yeah, even if like we need a large amount of CPU and memory, then we need to go for a higher compute. Otherwise, we can go with the lower one. And the main thing is we can like scale out or scale in, like we can increase the number of nodes that we have according to our demand. Okay, so these nodes can be like we can create more replicates of these nodes actually. So we can increase according to the demand, and we can like decrease if that it is like that spike is not happening.
Okay.
So mainly in Azure AKS, what happens like there are mainly AKS will support Ubuntu. Okay, Ubuntu it will support, and also yeah, we can call it as Ubuntu Linux. Then there is one Azure Linux, also Windows Server 2022. Okay, these three OSs it will support.
Okay.
So it is like so the idea is like whenever we are creating an AKS cluster, or we are just scaling out the number of nodes that we have, Azure do what? Azure platform will automatically creates and configure the VMs, the number of VMs and all. We don't need to think about it.
Okay.
Okay.
Which VMs are the Kubernetes VMs?
Yeah, like here no nodes, the VM node.
Yeah, nodes. Right.
Yeah, so it will increase the nodes and it will be like that VMs will be created automatically. If we have that,
Okay.
like let's say we just configured, we may have maximum 3 nodes. Then currently if we have only one, we are getting more traffic, then it will scale up to 3. That's it.
Okay. But sir, what about the containers in each node? We got the containers, right? Currently, we got like 2 containers in virtual machine 1. So, I mean, Azure, like, would it also like increase the containers as well as, or I mean, just the virtual machines, just the nodes?
Yeah, means it will copy the, like it will create a replica, or it will make a copy of the entire thing. So for example, the entire VM itself. So everything will be there, container and all things will be there. And this container
Okay.
we will be creating with the help of some YAML files. Okay.
Okay.
Okay. So on the next session, what we will do, right? We will deploy containers. Okay.
Containers.
Yeah. So
Okay.
you will get an idea. But the thing is, you just need to go through this architecture, because mainly we will not be seeing this anymore. Only containers
Yeah.
and all will be taken care, and we will be using some kubectl or something to connect to it, like that. So managing and something.
Okay. But sir, this kubelet and kube proxy, I mean, these things would be there, right? And I mean, are we going to decide that are we going to do some stuffs with that, or I mean, would it be gonna there all the time? I mean, we
Yeah,
just have
it
to.
will be there. It will be there. It will be created
Okay, it will be there.
automatically. So
Okay.
mainly we need to concentrate on this part. If we need to
Okay.
configure networking, then we need to like actually that services is called proxy, but there is no like a block called proxy. We need to get inside to that. It is not like that. It's a service
Okay.
that we have over there.
Okay.
It will be over there. Like we don't need to configure anything.
Okay.
If we
So we
need to
just need to
restrict
focus on the
something,
container.
that kind of things, or some kind of advanced kind of things that we need to perform, then only we will be like mainly doing those kind of activities.
Okay. But mainly we will be focusing on just the container part, and rest of everything would be managed by the Kubernetes. And this side, the control plane would be managed by the Azure.
Yeah, control plane will be managed by Azure. These kind
Okay.
of services will be available there, and
Yeah.
we can like if we need to configure some extra configurations, then yeah, we can use those. Otherwise, like it will be a structure that we will be having in place when we deploy a cluster.
Okay, sir.
Okay.
But sir, like if while comparing like this whole Kubernetes to Docker now, so Docker is like way more simple. I mean, Kubernetes is on the next level. It has many stuffs in it.
Yeah, definitely. Docker is like it's a containerization technology, right? So we can create image, and from there we can create container. Okay. So here what happens is, I can say that, for example, we have a Docker file. Okay, we have a Docker file. From that, we build one image. Okay, I will take this as an image. Okay, one image we created. So now we have one image. No?
Yes, sir.
And we can store this image somewhere. Okay, and we can create container from this image. No?
Yes, by running it.
Correct, by running it.
Yes, sir.
So we can decide, yeah, whether we need to container over here. Yeah, we can do that. So this Docker and Docker container and all is something like what? Encapsulating, like creating an image and running that container. But here, how we manage this? Correct, because we are only saying about containers over here. We are not saying anything on images. Right.
So, sir, is it like this? So these containers like C1, C2, C3, so those were already created in Kubernetes, right? Or I mean, those are the
No,
Docker
that we need to
containers
create. That we need to create.
by the
I
Docker,
just
right?
took it as an example. If we need a container with with an application running, then we need to mention that. Otherwise, it will not be there. I just took an example.
Okay. No, sir. Is it a Docker container or a
Yeah,
Kubernetes
either
container?
should be Docker container, no issues. Like for example, it will be like referring. Yeah, this image is stored in somewhere now. So in Azure,
Yes.
there is one. It's called ACR, Container Registry. Okay. So these images can be stored in this container registries. So this AKS can pull this image from there and they can provision containers. So what will happen is it will go to ACR and then it will fetch the image and create the container. Like that's also fine. It will be also happening.
Okay.
Okay. Either we need to create like a KS container like Kubernetes with the help of a YAML file. Okay. In this file, we can mention, okay, one image is there in this ACR. Okay, one ACR is there. So go and fetch it and deploy. We can mention that in the YAML so that it will deploy.
Okay. No, got it. So it means like after creation of the container, whether it has been created through Docker or YML. So after creation of that, and when these containers like goes into ACR, and then this Kubernetes picture comes into place, right?
No. In ACR, only these images will be stored.
Okay.
No containers will be stored here.
Okay.
Okay, containers are in this kind of virtual machines itself.
Okay.
ACR is for storing these kind of images. For example, if we have multiple kind of images, we can store there and we can refer that image. From that image, we need a container like that.
Okay. But sir, so far, like we know like how to make a Docker container, right? Because we have created like in the previous sessions. But what about the YAML containers? Like we cannot create it, right?
Yeah, that kind of things we will take in the next session.
Okay.
So we'll be mainly into YAML and how that deployment is happening. That we will do the lab in the next session.
Okay, sir. Okay.
So just try to understand this.
Okay.
And
yeah. Okay, sir. I mean, I'll also go through with the previous video as well. I mean, the Docker container video as well. For the better idea.
Definitely, you have to go. That's why I told in the starting of the session itself, you need to refer this video as well as the previous one to get an understanding, and then we'll do the lab. Otherwise, like it will be like a lot of confusing things because there are a lot of things. When it comes to interview, sometimes they will ask, okay, what is kubelet? Okay, then we need to describe, okay, kubelet is something like an agent which will reside inside the worker now that will be managing the containers and all, and it will be like communicating the details with the control plane.
Okay.
So like that, or what is container runtime? Okay, container runtime is something like it's a platform or a software that will set up a platform to the container to run and interact with the resources, like that.
Okay.
What is an API
Yeah.
server? We get like those kind of questions that we may get in interviews. So we can say that, okay, API server is something like it is a server that is an API server is exposed so that we will be accessing the containers, the Kubernetes clusters with the help of API server, and it just reside inside the control plane.
Okay. Okay.
Also, you may get questions like, what is the difference between managed and self-hosted Kubernetes? You can say that, yeah. Generally, we will have control plane and worker plane in Kubernetes cluster. When it comes to managed Kubernetes, what happens? Control planes will be taken care by the provider. But in
Yes.
self-hosted, we need to take care of both the planes. Like we need to take care of control plane and the worker plane as well.
Yeah. But in the most of the cases, like I don't think so. It happens in the in general.
Sorry, can you repeat that once again?
I mean, in the most of the cases, I don't think so. It would be it would happen in general, like both like self-hosted Kubernetes, like managed with buyers.
Yeah,
Like
it is like, yeah, it's like in different use cases according to the requirement.
Yeah.
Mostly,
specific cases.
most of the clients are leveraging to manage Kubernetes.
Managed.
But yeah, there may be some requirements that they need self-hosted also. So that's also.
Okay. So, sir, another question, like in a simple way, in a simple words, like, is it okay to say that after creation of a Docker file, the Docker containers, this Kubernetes things like comes into place? So, Kubernetes is the continuation of the Docker container, right? I mean, would it be okay to say like any container?
Yeah, it is like, yeah, Kubernetes is something like managing the containers that we have. So the
Okay.
containers that we created with the help of Docker or something.
Docker or
Okay.
YAML, anything. So it's a
Yeah, we
continuation
can
then.
manage the containers. So Kubernetes mainly into the containers. It will
Okay.
not concerned about the image that they have. Whether
Okay.
it may take directly a container, it will create a container, or it will refer some image and create a container. That's the only thing a Kubernetes will be concerned on. The creation of image and all will be taken care by Docker itself.
Okay. So it's only I mean the Kubernetes only cares about the container, that's it.
Yeah. Containers
Okay,
means,
sir.
okay, if it say container, there will be storage that needed for an application. There will be
Yeah.
networking parts that we have. So all that comes in that, but the image and all will not come there. Image is different. Image we can store in ACR, Azure Container Registry, and we can refer that to create a container.
Okay.
It's like
Okay, so
if we need to do so, like we can refer that in YAML file and like that. So mainly two ways to create this Kubernetes cluster. One is using the command prompt and one is using the Azure portal. Yeah, for that, yeah, that part we will discuss the next section.
okay, definitely, sir, definitely.
Yeah, I think this should be fine for now because otherwise, like, it
Yeah.
should be
Yes, and no more doubts. Everything got sorted, So
yes.
thank you so much.
Okay. Yeah, so yeah, I'll be sharing that recorded session later. Do follow that and do follow those. Yeah, I'll share the repo also so that you can refer it. Are you getting that repo and is that helpful?
Yeah, yes, sir. I also like I mean, done the same copy paste thing like in the last, yesterday itself. So, I mean, for creating Docker file and also I have took everything from there.
Yeah, okay. Yeah, I'll be sharing this also.
Okay. Sir.
Okay. Yeah, thank you. Thanks for your
Okay. Thank you so much. Thank you so much.
Bye.